Introduction to Surds. Now let us look at some square root. Take for instance square root of 4. The square root of 4, as we know, is equal to what? 2. Good. Also, let's look at another value, the square root of 9 over 4. The square root of 9 over 4, the square root of 9 is what? 3. Good. And the square root of 4 is 2. So if we simplify further, 2 and 3, that is 1, remainder 1 over 2. Good. So some square root can be evaluated as whole numbers or fractions. In other words, they are rational numbers. Alright? But what about the square root of 2? Or in another case, the square root of 3. The root to these two square roots are not whole numbers or fractions, and so they have irrational values. Alright? They are usually written as decimal to a given approximation. Alright? So for instance, the square root of 2 to 5 decimal places is 1.41421, and the square root of 3 to 5 decimal places is 1.73205. So when we have square roots which gives irrational numbers, as we have the square root of 2 and 3, we call these numbers surds. Alright, and there are other surds. Okay, we have square root 5, square root 6, square root 7, square root 8, square root 10, and so on. Alright, good. So now take note, if a positive whole number is not a perfect square, as we have in the square root of 2 and the square root of 3, they are not perfect square, so they are called surd. Alright, so the square root 4 is a perfect square, so the square root of 4 can now be called a surd. So if you have a positive whole number that is not a perfect square, then its square root is called what? Surds. So that's why we have square root 5, square root 6, 7, 8, 10, and so on. Can we really find real life uses of surds? Yes. Surds are frequently used by scientists and engineers in precise calculations such as building rockets. Surds are also useful in approximation of answers. Okay, good.